Okay. Okay. So, hey everyone. I think as we were like advertising this like from last 15 to 20 days, this is something which I've been working on since the beginning. So, so the thing is, the application which we made on daily basis are pretty much in a reactive fashion. Okay, they take some information and do some operation on that and then change themselves based on the new information which they internally change. But they also propagate those changes to other part of the application, and which is very important because when you propagate those changes to other part of the application, those part of application also needs change. So this is sort of my journey that how I started working with React and how I found it that it's one directional of data flow is pretty much leaving me with some specific aspects which I was not able to make my application fully reactive. And then I started exploring that how I could be pretty much more into those specific aspects where I can make React a little bit more reactive to actually perform some places where I needed two-way data binding and stuff like that. So this is the whole idea, and the agenda is straightforward. I'll be getting a little bit introduction that what is React and a little bit about Redux. I'll talk about a little bit introduction to reactive programming, what is and how it works. I'll also talk about some challenges that I've faced with React, actually in React with Redux. I'll also introduce you to RxJS, not in very depth, but a little bit like how observables and operators are, and then I'll make a very simple example that how you can make React a little bit more reactive when on the places where you actually need it. So what is React? It's actually, as per this documentation, it says that it's a JavaScript library for building user interfaces. What it means is like, so in your front-end app, if you follow certain architecture like MVC, where your model, view, and your controller is pretty much reside on your whole front-end code base. React is represents view layer of that particular architecture. Uh, uh, how it works is just take any specific UI, and you can divide it into multiple sub portion of the UIs, and those sub portions of the UI can be built independently in React, and that have a lot of feasibility and lots of advantages to that, because now you can have multiple people working on multiple smaller part of your application, because you are just uh, using a smaller portion of your application to build and then combine them into one. So those kind of things which done on React, but it's purely built to actually build user interfaces. Some of the terminology which React uses is component. The component is the least building block of React app. Like every specific app at least be having one specific component, and as your application goes in more complexity, you just keep adding components, and as you divide your application in multiple portions and multiple parts, each time you build a new component to that specific part of the application. Then the components comes with lifecycle methods, specifically the class-based components. Uh, and these methods are which to give you kind of hook or give you kind of control in a React rendering process. Like when is what, so in a specific event, what sort of things is happening inside the React, these callback and these lifecycle methods helps you to do certain operation on those specific point of time. Props is another terminology which is simply means properties. It's an acronym of specifically properties, and what it means is like if you want to provide React some with some initial data, that can be done through props. Similarly, in our input control in HTML, like if we have to provide that what type of input control we are generating, we simply pass type as a actually type as a property, and then its value like email, date, and specific stuff. State is another way which data is handled in React. It's purely internal, and it's stick to the React component only. State propagation is not directly enabled or directly available. So every specific component holds its own only its own state, and that which it can change and that what it can operate on. So it's very internal, and it's I can and you can say it's private to that specific component only. So let me get you a little detail about what lifecycle methods we have. First thing, I have divided them into 4 and 5 categories to just take them a little bit more understandable. And this is the order actually they get fired when these specific type of operation happens. So mounting means when your component is getting mounted on the view, like that's the first time, no updates happens, nothing happens. You define a component, you include a component to a React page, or maybe you mount that actually enable that component to your specific document node, or maybe document root, whatever you want. And then the mounting process happens, the first render process happens. So first thing what it get called is constructor, and then there's a static methods as well. So every specific component, because server side rendering is also there, so there are some specific static methods is available which you can call on the server side to get the specific information or send the information back to the component itself. So and then render, and then finally component did mount. So this is what the mounting process happens. So anything if you want to execute after your component mounted onto the view, you should be writing those specific statements in component did mount. Any specific information which you want to be available for your specific component before it get mounts, you should be writing on your constructor or maybe in render function, depending on how you need it. And then the second stage happens is one is component in mount, and then you pretty much either change the props or either you would set a state internally. You get into updating phase. What updating phase happens is the first thing it's get called. So as you mentioned actually, as you can see in update in actually update phase, the constructor is not called again, and you start with get derived state from props, which is the second function called earlier. And then should component update called. Should component update is a kind of Boolean operation which Reacts check internally that either I have to be re-rendering this component or not. And if you want to implement this function should component update, you have to write that different logic by your own. So you can provide a different logic for that specific component, that when that component should be re-rendered and when that component should not be re-rendered. This method should be returning a Boolean value, either true or false. And then after that, if your should component update returns true, then the render function get calls. And then after render function, you can also you have another callback which gets you snapshot before it's getting updated. So that this combination of function you can use to store any specific snapshot if you want, and do some operation on top of that. And after that, component did update happens. So after your DOM diff done and DOM changes happens, component did update get fired. The unmounting state where component is just removing from the view, like you are suppose you have a one specific router and that router only uses one component, and then another router uses another component, and you are moving from router A to router B, then the unmount will happen on route A component. So that in that particular state, component will unmount will be fired. There are two specific methods for error handling. One is static and one is instance based. That is called component is catch, and the static one get derived state from error. So this will gets you if React internally throws some error while doing some operation in your component in their diffing and specific internal use cases. You can use this to catch those specific errors in your component specs. There are two other APIs. One is to set state. So state is not directly accessible through the component either. You can define a state which can be accessible accessible like any class objects, but updating them require a lot of other things which React internally does. So that's why you have a method to update your component state, which is called set state. How set state works is you pass an object to set state, and it checks that what object it have on uh, it actually state property, and it just merge them two, and then check if there's any specific difference in that, and based on that, other updating life cycle happens. And then there is a force update. If your React component does not getting updated automatically by its diffing algorithm, you can forcefully update them to do some operation that you want. So this is a typical React component looks like. It's a counter. It have a state which say count equals to 1. It have two specific method, plus and minus, and then it's have a render property where you can define what your component's gonna be look like, the HTML part of your component. I mean, the pure UI part of your component. And I'm just using state.count, and I'm just increasing and decreasing using these specific two methods over there. You can see like on set state, I'm first incrementing the value and then assigning it to state. So that's how it can be done. And if we want to provide default counts through props, this is how you can do that. You can just use a prop on the count, and then you can use that prop into your constructor or any other lifecycle method where you feel like that's going to be reasonable, and those kind of operation you want to perform in those certain point of time. And then the challenges which you face in this specific React structure is sharing data among components is very difficult. If your component is a child of some parent, then parent can pass the information to child directly through props. But each time that data gets changed, your parent and your child both get rendered. So that's the one specific thing. But if you're having two parallel component on two separate places, sharing data within them is not directly available. And that's and as I mentioned earlier, state is very private to that specific component only. So, and the state cannot propagate back and forth and stuff like that. The other challenge in this particular React structure is because now, as you've seen, like we are writing logic and UI on the same specific file, same specific component. There is no separation of UI and business logic, which make your React component a little bit hard to test. Like you have your business logic into that, you have your UI into that, and they are tightly coupled. So in future, if you want to do some segregation or some specific refactor, you have to refactor the whole component rather than just updating a little piece of code on your UI, or maybe a little piece of code on business logic. And the third thing, because there is a way we can pass the data from to our child component through props, I feel that props are a little painful. And the reason behind that is because props can introduce a lot of complexity and needs to have a deep understanding that how component life cycle works, so that you can check whether you need to update your component, or specifically you can manipulate those and get the latest value from the props itself. Because as you've seen earlier, if you're just using props in the constructor, you'll be getting that value at once, or every re-render cycle that constructor will not be get called. So you earlier there was a function called component will receive props, which they have removed recently, and that was the function where you can get each time which get called each time your component receive props. So now they have to do that. Now we have to do that component should update, or component will update specific methods over there. So I find props a little bit complicate the scenario for the beginners. And if you're really into React, and if you're really building and having a good understanding, it could be easy. But for me in the beginning, it was a little bit difficult. So that's why I mentioned over here. So as I mentioned, sharing data among components is hard. So and that's where we introduce Redux. So what Redux is a predictable state container for JavaScript apps, and it's simple a PubSub model implemented in JavaScript, and w- w- actually what it provides is it's provide one single global store in which you can store all your information, and that information can be accessed by any specific component which connect to that store, and then they can have the data available with them. So in actually as the terminology goes on Redux, it have a reducer which is a callback method for Redux, which get calls. So in PubSub model, you have a publisher and then you have a subscriber, and that subscriber needs a callback, and then this reducer are those subscribers callback. Actions are simply a way in Redux by which you can tell some information to your store either to get update or to get manipulated. So these actions are generally pure function which get dispatched, which you need to dispatch so that your store can listen to them and call the corresponding and actually you can pick those specific action actually in your reducer and manipulate your store accordingly. Create store is a method which take these reducers and pretty much create a store out of it. Map state to props are actually a callback which lets your store properties and your React component props actually map those state to your props, and the dispatch is similarly happens with actions. So if you see like a typical Redux action, you just have a plus function and you have a minus function. I'm not using payload over here. I'm just using type because payload can be null. Type is what it requires. And then this is a simple reducer. You can see reducer is just a function, and I'm using state, which is a default state, and then action. I'm just having a conditional statement on action dot type. In case of plus, I'm just incrementing the value. In case of minus, I'm just decrementing the value. So, and this is how you can create Redux store. So this is the one counter which I have. So this one is the counter one, and this other one I've just taken sake for the example so that I can tell you a little bit how combined reducer works and stuff like that. So these two specific pure function which I've created as a reducer, and I'm using this function to create my combined store. And this combined reducer method is also available on Redux, which lets you combine multiple reducer functions into one. And in this scenario, I'll be having two specific property in my store. One is counter and one is other. And in counter property, I'll be having count, which initial value would be 0, because in default we return. So there's one other thing missing in this particular code, which is like there is supposed to be a default case in which we have to simply return the state. So each time this reducer get called, it should be returning state. And then we have to connect this specific the component which we have built earlier to the Redux and to that particular store. There is another declaration of provider which takes store as in property and stuff like that. I'm just not mentioning over here, but this is how you actually connect your one component to reducer. So as you see that I have a map to state prop function which takes state as an argument, and then it's asking that what property you want to map what property. So I'm just simply mapping count to state.counter.count. So I'm getting that counter value from the reducer itself. And then the second argument to the connect decorative, I'm using map dispatch to props, which simply I'm importing all the actions which I've created on the action file, and I'm just simply mapping plus to plus and minus to minus, and then I'm just using those things through the props directly. So now you see that I have to remove state completely. This counter is completely managed through props as of now. But yeah, still the logic is there, and still everything is there. But now I'm just introduce a separate storage independent store for this specific component, and this become a connected component over there. So that's all about React so far. Let me see if there's any chat message.
Hi, Ashok. Can I ask you a quick question?
Yeah, sure.
Hey, just going back to the last screen, right? The map to state props and the map to dispatch, right? Is this like I want to say the pretty much the standard way to write it, or is it because I usually do it with like the connect at the bottom, like when you export it?
Yeah. So this is the decorative way of doing it. So JavaScript does have decorative syntax as well. Like @connect method you can see over there now, and that method is decorated on this class counter. So either you can call that method and export it through calling that method into the
What would
counter,
be the
or you
more
can.
standard way to do it? Like this way or the other way? I would say. Like,
So both are pretty much standard way. Ultimately, if you're gonna use Babel or anything else, it's gonna get compiled to that method which you're mentioning. So both are into the spec, and both are like if you take an example of TypeScript React, okay. And so most of the example you will see in this way, and if you're not using the TypeScript examples, you will see the other way which you're mentioning, like connect would be a method, and then you are passing your maps state to props and your map dispatch to props, and then calling that method and passing your React component into that.
all right, thank you.
Yeah. Okay. So this was all about what React is, and what sort of things we do in React, and how that is pretty much working out so far. So let me give you an introduction that what reactive programming is. Uh, it's a programming paradigm which orient around data flow and propagation of change. So the thing is, which I mentioned earlier, is because nowadays the way we are building our web apps, or maybe any app specifically, these apps are tend to have to deal with a lot of data, and as per the data gets changed, multiple portion of that application needs to change, and that's where reactive programming come into the picture, because propagation of those changes from one place to another is not very straightforward in most of the front-end languages. So to, to to understand it better, take this particular example. This is spreadsheet, okay? Like if you go on Google Docs, or on spreadsheet section, and you simply pretty much open this and put this particular information, you can put a formula over there, like which can calculate the sum automatically. So if I change anything, like I made quantity 2, the total will be updated automatically. Or if I change price, similarly happens to that. So this is what reactivity means. Like if my total depends on these two specific data, and if any change happens to those specific data, my total should be get updated. So that's what reactivity in general means, and that's what reactive programming is pretty much keen to concern to enable these kind of features in into the application and the software we built on daily basis. But JavaScript is not reactive. So if we take this particular example where I have two specific variable and I am computing a total out of them, and I'm logging them, which is 20. When if I update this dependent variable, which is a, after I've calculated my total still remains same. So that's mean reactivity is somehow is not there. And similarly, if we go on React documentation and dig a little bit, which is the scheduling portion of design principle of React, it clearly mentioned that React is not fully reactive, and that's why it's always having that one specific mindset, like the data it flows from top to down. It does not have a two-way data flow mechanism, and reactive and making anything reactive, that's two-way data flow mechanism is required. So because of those specific things, like why it's important to you, and why it matters, the first thing which I mentioned many times, apps becoming more reactive every day. When reactive is not there, when you have to deal with network calls and any specific live data or any specific future events, all the only thing you have available is callback. And we know that callback hell was very major issue and very specific concern for everybody who is dealing with callbacks. We came up with promises, which are, I don't see them as a solution to callback, but because promises are itself a callback. Now you just divided them into a nice wrapper, but that doesn't mean you are out of callbacks. They're still using callbacks, and you might, if you have dependencies like from one promise to another to another to another, they're supposed to be a callback hell specific situation. You're gonna get, like, you're gonna have then, and then inside then you're gonna have then, and stuff like that. There's another mechanism comes recently in the picture, which is called async await, which is sim, simply is a different implementation of promises through iterators and through observable. So those specific things which making things differently, and that's where I suppose the reactive programming is supposed to be. This reactive programming also makes your async and threaded works pretty simpler, because it uses observable which you can subscribe to and which you can combine to, or do all sort of operation you want over there. It have lots of operators, and that operators simplify a lot of work for you. Like if you want to make a pull request, uh, a poll kind of mechanism where every specific second you want to make a AJAX call to some specific place, whether that's get completed or get failed, you need to do some operations. Simply you can just use timers over there in JavaScript, or in an observable you can just use observable dot interval on and stuff like that. So there are a lot of helper and operators, helper method which we call operator in RxJS, which is available. And because you start writing services and you start separating your business logic to your UI, your code become a little bit cleaner, because now your producer and your subscriber are completely in a different place. You are just using those specific methods in your UI layer so to actually conduct the whole application. So your code become a more cleaner, readable, and stuff like that. So in that regard, what I face is challenge in React with Redux is because Redux introduced a single global store. So most of the time what happens is like I built an application which require various label of data authorization and data authentication mechanism, and then sharing that one global aspect, so any specific developer can peek into the current state object which they have, and they can either assign those objects accidentally or maybe by means to specific component which doesn't require that data. So having a global store poses that certain problems. Reducers are called even when this is not in use. So there is no such mechanism in React with Redux to unsubscribe those specific reducer which you have already connected to. So once you have connected to your Redux, your reducer gonna get fired, either your component is in the view or not. And that's why you have that switch operator over there, where you can pretty much check that if the action is something which is for your use, then you need to manipulate your state accordingly. The other problem is faces is because actions have only a name, actually type to identify. Now you are also getting into that specific a specific state where everybody need to think about their actions, because if your application is very big and everybody is writing their actions their way, you need to have some sort of understanding that your actions and my actions would be different in certain ways, so that we cannot invoke our Redux to be changed in those specific portion. Otherwise, we'll be causing some serious challenges to our application. And because these actions are simple, pure function, and we tend to call our AJAX request and a network expression to that, now we are moving a little bit more boilerplate code into our into your whole application. And because these action also requires to be introduced and mapped to our component, so somehow our separation from UI and business logic does not happen the way I wanted. I mean, I'm still mapping to the specific properties I need from the store. I'm still mapping what kind of action I should be using. I'm still calling my state variable. I'm still using state inside it. And now it's become a combination of props and a combination of state to be to make my application run the way it's supposed to be. And props, as I mentioned earlier, why I found props a little bit painful in that specific area. So in so any questions so far?
So I don't see any questions, Ashok, in the chat.
Okay.
Yeah.
Okay. So RxJS is a simple utility for composing asynchronous and event-based programs, which uses observable internally, and I'll be letting you know that what observable is, and we'll discuss a little bit into that. But think about RxJS as in low dash of events. Okay, so so the terminology for RxJS is straightforward. You have observable, which are lazy collection of multiple values over time. So what does it mean is you define one observable, and that observable will not only have the values, but it also those values should be assigned to those to specific time as well. Like what time actually what point of time that observable had contain that kind of value, and the way you subscribe to those specific observable, you'll start receiving those values in that time fashion only. Observables are lazy because when you define them, they don't do anything unless you subscribe to them. And the second word you might be hearing is observer. Observer are a collection of callback or list which listen to any specific observer. Like these specific. So generally these observer contain three methods. One is next, and one is error, and one is complete. And most of the time we don't use all those functions. We just work with next at the most of the time. Subject is also an observable which have only one specific subject, which can be defined while we are initiating them, or which can be defined internally through RxJS. So all our subject will be unique internally, and whatever observer we send to those specific subjects, those will be only get fired when that subject is getting changed and stuff like that. Operators, as I mentioned, pure function which deal with observable with operations, and these operations can be so many stuff which I'll be talking. So to understand a little bit about observable, let's take an example of drag and drop and how it works. So in general, drag and drop, what happens is for each mouse down on your target, you start listening to mouse move on the document, and then you keep listening that specific mouse move until your mouse up on the document get fired. So if you see three major and important stuff needs to be done before you implement drag and drop. First, you need to identify a target and implement a mouse down event handler on top onto that. Then if that mouse down event happens, then only you should start your mouse move on the document. And as soon as mouse up happens of the document, you should remove that mouse move on the document. A JavaScript implementation of this is very straightforward. Like you just simply attach an event to your image lesson and stuff like that. But in uh, in an observable pattern, you simply do this. First you select your target, which is simply documented query selected, and then you create a mouse down event handler, which is observable from event, which I'm passing target, which is my on which my event from which I'm actually picking the event, and then I'm using mouse down, which is my event from this target, and then I'm defining a mouse move, and then I'm defining a mouse up. So because I've defined this, there would be nothing done. There will be no event to listening until unless I subscribe to it. So my drag and drop event becomes simple. I'm using some operators over there. So on mouse down, I'm using switch map, which let me pick either one of it. Either this particular callback exists or this particular callback returns nulls. In case of null, the drag and drop will be complete automatically. The switch map helps over there a little bit. This is an operator function for observables. And then on mouse move, you see that I'm using another operator function which is called take until. So my mouse move. So whenever my mouse down gets started, a mouse move will be binded until a mouse up is get fired. So this is what we wanted to implement here, and this is what is going to implement here automatically without having any if else and stuff like that, which we need to do manually in case of plain JavaScript. And if I compare observables to promises, I found them very similar. Okay, so here on the left, you see that I have a promise which I have a then method, and in the then method we are using success and error, which is a two callback, and similarly in an observable we actually subscribe them. And on the subscription, we use next, error, and complete method. But in reality, most of the time, what happens is in the promises, we just ignore the error part, we just use the success part. Similarly, in observable, we mostly ignore the error and complete part, but use the next part. So if you see, they are very similar to each other in terms of implementation, but what they can do is completely different. A promise can only have one possible value. Either they're gonna be resolved to the specific data or they're gonna generate some error. That's what a promise means. But an observable can have as many as values generated, as many as time the next is getting called internally. It can get you an error if some error happens, and ultimately it's gonna get complete, which means when it's gonna be completely done. So that's what the basic difference between observable and promises. Let's move to operators a bit. So operators are plain function which takes an observable and return an observable, and these function can be map, filter, scan. I have a simple implementation of map function actually, and that and you can see that I'm just asking you to give me an observable, and then I am asking you to give me a map callback, and I'm using that observable to just map my next method with your callback and getting you the data into that. So that's simple how observable works. Actually, how operators works. They are just simple pure function. You don't have to be so much worry about that. So most of the time, what I've seen in people when they are started with RxJS or maybe started using with RxJS, because there's a lot of operators, they are still very confused that which one to get started with and which to use in. So that's gonna come when you start using these operators, and you're gonna do some mistakes, and then you figure it out that what makes sense on what specific places. But my suggestion would be start with map, filter, and stuff like that, which is very minimal. Start with interval if you have some kind of polling and some kind of time specific event to be happen, and specifically do all those specific things in that particular order. So let's make those specific things which Redux was not able to do in the React earlier. So now what I'm doing here is I'm just introducing a new concept in React called service. So here you can see I'm just creating a counter service which have one specific job. It's gonna create an counter service observable, which gonna have three specific method. One is plus and minus, which it simply happens by subject dot next plus this count and stuff like that. And then there will be another method called subscribe. So anybody any specific JavaScript class or any specific function can subscribe to this specific service. And the way we are using it in our component is straightforward. I'm just using it in my constructor, and as I mentioned earlier, that every subscription, every observer return a subscription which you can unsubscribe to any specific point of time you want to. So now I have just removed props completely from the system. I'm just using this counter service directly. You can see this dot subscription is simply a subscription to the counter service, and whatever value I'm getting from that subscription, I'm just setting them to the state directly. I'm not using any props or anything else. My default state is count1, and then when component is getting unmounted, I'm just unsubscribing to that particular subscription. So this way, what I did is I completely remove Redux from the picture, which remove the dependency of props from the picture, and it simplifies my UI only contain a subscription and the UI. My all business logic is move to the service, which we are writing, and these services are independently testable. So I can test my business logic separately and my UI separately based on the data I've created for my services. So in conclusion, what happens is now my data is divided into multiple subjects. So each time I define a new service, I'm actually going to use the subject notation. There is one other called behavior subject. There is another called observable. You can use any of them, but I'm using subject because subject is more into that particular way. Either you pass a subject name or you don't pass a subject name. Internally creates a new subject name automatically, and which lets you do this counter service to be unique. So anybody who is subscribing to this counter service will be only get fired when something gets changed onto this counter service, not throughout the application. So now I can divide my application into multiple models and multiple services, and then our application, the portion of application can subscribe to those services and listen to the changes those specific services are making, and based on them they can change themselves using this state method. And they can also propagate change from UI to services through the service function. As you can see here, counter service dot plus and counter service dot minus. So this is I have pretty much enabled a two-way mechanism of data flow from my component to services. And because now I don't have to define and deal with actions and reducers and the way to connect them with each other, I have to write pretty less boilerplate to make my application have the share of data from one component to another. As I mentioned earlier, business logic is moved to services, and no props is being used. So this is all. I just would not be actually couldn't get enough time to put a thank you slide. So I think that would be the thank you slide here. Any questions if anybody have? I'm just listening to that.
Yeah, we have a question from Cliff in the chat window.
So my idea of learning any specific tool or any specific library is to first getting started with their documentation, that what they are saying. So reactjs.org, as you mentioned, to learn React it's something where you should get started. But another idea behind that is if you know any other programming language, any other library or framework like Angular or anything else, just try to relate them. Like try to do things which you could have done in the framework or library you already know, and then you have a purpose in front of you, that what your next course of action is supposed to be. And most importantly, start building something for yourself into that specific library. Most of the time what I do is, if I have to learn any new library or any new specific programming language, I just pick one of my old project or maybe a new project, something which which I might be creating for myself only, and then start building that particular project in that library or that particular programming language. The main advantage with this approach is because you're gonna have a problem every time you're gonna stuck, and then you're gonna search those problems in the internet, find articles, you start digging through that, and each time you have the next item on your plate directly. So I think that's how you should approach it. And any specific way, if you want help, the community is also very big. People are writing a lot of answers on Stack Overflow, and they have the specific channels for React specifically on Slack. You can join them.
So Ashok, is there like in the CLI or React CLI, they can directly use RxJS, or it has to be done separately?
No, as I mentioned earlier, because React does not want to be reactive. Okay, the React have very unique purpose, and that's why it's built that way. So they will not get you that particular thing directly in React CLI and stuff like that. But because your application demand such specific portion of application to be React. So simple example, you might be building a cart for your e-commerce application, and cart needs to be very reactive. Okay, so you can build your cart portion this way, and rest and the other portion of application the way you're building with React. So that kind of mix and match you should create when you are going reactive with React. I mean, not 100% of your application needs to be reactive. There are certain portion which can be managed through one API call, and later on when lots of other operation happens. But yeah, learning RxJS could be very beneficial, because I simply as I shown that example of drag and drop, you can see that how much simplify event handling it makes when you when you deal with observables and handle it with RxJS. So that would be one thing over there.
Thanks, sir.
Anything else?
So I just shared a link for like anyone, if they're interested to learn RxJS. There is an animated view to learn each method.
Exactly. React RxJS also have a documentation site which is built on Firebase, so you can go check on that. Reactive.how is more on a reactive programming, what sort of reactive programming paradigm you should understand, and they have example from RxJS, but their RxJS also have a documentation site built on Firebase.
Yeah.
Firebase. So that's also you can check out if you want to dig deeper.
So any other questions from?
Okay then.
Yeah. So
I think you already have shared my social details with the people, though, so they can contact me over there. I'll answer them directly if they have any.
Yeah, sure. Yeah, I will be anyhow sharing all these details again through email. And thank you for speaking to us, Ashok, and thank you all for attending.